Hello and welcome to this software testing course. I'm Bo Carnes and I created this course. In this tutorial, you'll learn all about software testing, from the fundamental concepts to writing your own automated tests, and finally how modern AI-powered tools are transforming the way teams approach testing. And here's what we'll cover. First, we'll explore why testing matters and look at some real-world examples of what happens when software isn't properly tested. Then we'll dive into testing fundamentals, the different types of tests, when to use each one, and the famous testing pyramid. After that, we'll get hands-on. We'll build automated tests using Playwright, one of the most popular JavaScript testing frameworks. You'll write real tests for a real application. And finally, we'll explore how AI is changing testing. I'll show you Kane AI from TestMu, an AI-powered testing tool that lets you write tests using plain English instead of code. TestMu provided a grant to make this course possible, and I'll demonstrate how it can make testing more accessible and efficient. By the end of this course, you'll have a solid foundation in software testing and practical skills you can apply immediately. Let's get started. Before we write a single line of test code, let's talk about why testing matters. Because honestly, writing tests takes time. And when you're under pressure to ship features, it can feel like tests are slowing you down. But here's the thing, the cost of not testing is almost always higher than the cost of testing. So let me share some real-world examples that illustrate this point. First, I want to talk about Knight Capital. So in 2012, Knight Capital, one of the largest trading firms in the US, developed a software update to their trading system. But due to a bug that wasn't caught in testing, their system started making erratic trades. And then in just 45 minutes, they lost $440 million. So that's not a typo, $440 million in 45 minutes. The company never recovered and was eventually sold. An even more serious example is the Therac 25. It's a radiation therapy machine from the 1980s. Software bugs in the system caused it to deliver massive radiation overdoses to patients. Several people died and others were seriously injured. These bugs could have been caught with proper testing. Then we have the Boeing 737 MAX. Software issues in the Boeing 737 MAX's flight control system contributed to 2 fatal crashes. Inadequate testing of how the software would behave in certain scenarios was a major factor. Now, most of us aren't building trading systems or medical devices or airplanes, but bugs in everyday applications cost money too. A bug that causes users to abandon their shopping cart, a login issue that prevents customers from accessing your service, a data corruption bug that requires hours of manual cleanup, security vulnerabilities that lead to data breaches. So studies consistently show that finding and fixing a bug in production is 10 to 100 times more expensive than finding it during development. That's because production bugs require things like emergency debugging under pressure, hotfix deployments, customer support costs, potential loss of user trust, sometimes legal consequences. So think of testing as insurance for your code. You pay a small cost upfront, which is the time to write tests, but then you can avoid potentially massive costs later. But testing isn't just about catching bugs. Good tests also serve as your documentation for how your code should work, give you confidence to refactor and improve code, help onboard new team members faster, enable continuous integration and deployment, reduce stress of releasing new features. So now that we understand why testing matters, let's dive into the fundamentals. So let's build a solid foundation by understanding the different types of tests and when to use each one. So here is the testing pyramid. One of the most important concepts in testing is this testing pyramid. This model, popularized by Mike Cohn, helps us understand how to balance different types of tests. So picture a pyramid with 3 levels. At the bottom, the wildest part, we have unit tests. These are fast, focused tests that check individual functions or components in isolation. In the middle, we have integration tests. These verify that different parts of your system work together correctly. And then at the top, the smallest part, we have end-to-end tests, also called E2E tests. These test your entire application from the user's perspective. So why a pyramid? The pyramid shape tells us something important. We should have many unit tests, some integration tests, and even fewer end-to-end tests. Because as you move up the pyramid, tests become slower to run, they become expensive to maintain, and more brittle and prone to breaking. Unit tests run in milliseconds. E2E tests might take minutes. Let's look at each level in detail. Unit tests focus on testing a single unit of code, usually a function, method, or class, and they're tested in complete isolation. For example, if you have a function that calculates the total price of a shopping cart, a unit test would call that function with specific inputs and verify it returns the correct output. Unit tests are fast. You can run thousands in seconds. They're reliable. They don't depend on any external systems, and they're precise. When they fail, you know exactly where the problem is. So here's an example. It's basically a simple unit test, and this is what it might look like in JavaScript. So we call this function the sum function, or actually the calculate total function. We call it with known inputs. That's these items here that we've created this items array. So after we pass in these known inputs, we assert that the output matches what we expect. So we expect the total to be 25. We expect that after we call this function, it's going to return the correct sum. Now, moving up the pyramid, integration tests verify that different components work together correctly. For example, an integration test might test that your API endpoint correctly reads from and writes to the database. Or maybe it may test that your front end correctly communicates with your back end. Or that your payment system integrates properly with a payment provider. Integration tests catch bugs that unit tests miss, bugs that only appear when components interact. So an integration for an API may look like this. So I didn't say this before, but this is basically the name of the test right here. And we are doing a post request to this API with this specific data, and then we're getting a response. Then we're expecting the response.status, the status of that response should be 200. And then we're going to verify that it was actually in the database. So we're going to call database.getCart to get the cart, and we're going to expect the items to have length 1. We're going to expect that this item is now in the database. So it involves multiple components: the API endpoint, the database, and their interaction. At the top of the pyramid, end-to-end tests simulate real user behavior. They interact with your application through the same interface your users do, by clicking buttons, filling forms, navigating pages. End-to-end tests are powerful because they test your entire system working together. But they're also slower, more complex, and more prone to breaking when your UI changes. So here's an end-to-end test example using Playwright. So Playwright is a JavaScript library that can basically programmatically interact with a website. So in this case, it's about user can complete a checkout. So we're going to the home page. We're clicking the element that has the text add to cart. Then we're clicking the element that has the text checkout. We're filling in this text field with this ID, and we're using this email. And then we're filling in the other text box with this ID card with this number. Then we're clicking the element that has the text place order. And then we're going to expect that the text order confirmed, there's going to be an element with order confirmed, is going to be visible. So basically, this is walking through an entire user journey just like a real customer would. So beyond these three main categories, there are other specialized test types. A smoke test, that's quick tests that verify basic functionality works, like checking if the application starts at all. Regression tests, these are tests that ensure previously working features haven't broken after changes. Performance tests, tests that measure how fast your application responds under load. Security tests, tests that check for vulnerabilities like SQL injection or cross-site scripting. Accessibility tests are tests that verify your application works for users with disabilities. Common question is, what should I test? So here's a practical framework. Test the happy path. That's the main way users interact with your feature. Test edge cases like inputs, maximum values, special characters. Basically, you don't know what a user is going to really do, so you have to test all these potential edge cases that maybe would be less common. Then test error handling, so what happens when things go wrong. Also, test business critical features, which are features where bugs would be the most costly. You don't always need to test everything. Just focus on what matters most. You might have heard of test-driven development, or TDD. This is a practice where you first write a failing test, then next you write the minimum code to make it pass, and then finally you refactor the code while keeping your tests green. Green means they're passing. So TDD can lead to better designed code, but it's not always practical. Use it when it helps, but don't force it when it doesn't. So let's summarize what we've learned. The testing pyramid, many unit tests, some integration tests, fewer end-to-end tests. Unit tests are fast and precise. Integration tests verify components work together. End-to-end tests simulate real user behavior. Focus your testing on what matters most. Now, let's put this knowledge into practice. All right, now let's get hands-on. I've created a simple e-commerce application called TechMart that we'll use throughout the rest of this course. It's a simple store where users can browse products, add items to a cart, and complete checkout. So I have all the code on GitHub. You can just check out the link in the description. We go into the sample app directory, and then I'll just do npm install. And then to start it, we'll just do npm start. Okay, so now let's just open a browser. We can go to this URL, and then we can just have a look at our application. Okay, here's our TechMart store. Basically, we have a homepage with these product listings. We have a filter, so we can basically filter by max price. We can sort. We can go to different categories, electronics or accessories. We can even search for products. So I can just type in mouse up here. We also have a login. There's a demo account information we can use to log in. And then after we've logged in, it says hi demo user up here. And I can add some items to my cart. And then I can go to my cart, see my cart page. I can proceed to checkout. So basically, we also have the user registration, the checkout process. This is a real working application with a backend API. It has products, a cart system, user authentication, all things you would find in a real e-commerce site. So we're going to write tests for all these features. Now let's set up our testing framework. So I'm just going to go back to our root directory for this course. And then I'm going to go to this folder cd/test/traditional. We're going to be using Playwright, which is one of the best testing frameworks available. It's created by Microsoft and supports testing across Chrome, Firefox, and Safari. So I'm just going to do npm install, and this is going to install Playwright and all of its dependencies. Now let me show you my Playwright config.js file. This is in that folder we were just in. And this configuration file tells Playwright a few things. First, where all of our tests are located. Also, it tells what browsers to test against. What we have this down here: Chromium, Firefox, WebKit, Mobile Chrome, Mobile Safari, and so on. And then it's going to tell where our local service, where our application is running, and whether to start our application before the tests. This configuration also sets up useful features like screenshots on failure. So that's what this is, a screenshot on failure, and then video on failure. So basically it will record video for debugging. So let's run our test to make sure everything is set up correctly. And now another thing you have to do before trying out the tests is to install the Playwright browsers. So I'll just do npx playwright install. And so this will install all the correct browsers that will be required to run the tests. Okay, now I can just run npm test to run all the tests that are already created for our application. And then I just have to wait. There are 265 tests already created, so I just have to wait for them to all run. Okay, we can see they've all passed. And then we can see the report with npx playwright and then show report. And then it's just going to open it into our web browser. So now it's going to show every test and then it shows the browser that it was tested on, like WebKit, Mobile Chrome, and we can search the tests. We can see which ones passed. None of them were failed, flaky, or skipped, but if there was, we could test that out. We could like search through them. Now I'm going to open up my test in my homepage.spec.js, and now we're going to understand the test structure, and we're going to start writing tests. Every Playwright test file follows a similar structure. We're just going to walk through this one that I just opened, the homepage spec. So first, we have this first line. First, we're going to import test and expect from Playwright. Test is used to define test cases, and expect is used to make assertions. So we have this test.describe homepage. So this is the test.describe is going to group related tests together. So this whole block contains all our homepage tests, like everything, basically all of this stuff here. Now we have this section, test.before each. This runs before every test in this block. So here we're going to navigate to the homepage. Basically, we're going to clear the cart, and then it goes to the home page before each test with an empty cart. That way, every test starts from a clean slate. Now let's look at an actual test. So we have the test, and then this is the description, and this is going to define a single test case. Now we have a sync where it says async page. That's going to give us access to the page object. In this line right here it asserts that the page title contains TechMart. So the page object is like a remote control for the browser. We can use it to navigate, click, type, and verify elements. Now let me show you how to write a test from scratch. Let's say you want to test the search functionality. So I'm going to go to the end of all these tests. There's already a bunch of them here. Should display product information correctly, should have a working search bar. Again, all this is in the description if you want to, or the code is in the description, so you can open this yourself and just check and just look at how the tests look. But I'm going to add an all new test here. So I'm going to do test should filter products when searching, and we get the page object again. Now the first step is to find the search input. So do const search input, and then I'm just going to set this equal to page.locator, and then I'm going to add an ID, search input. So basically, whenever we use page.locator, it finds elements on the page. Then we use CSS selectors, or we can use text content or other strategies to identify elements. So in this case, we just use the ID. So the next step would be to type our search term. Remember, we're simulating a user here. So I'm going to do await search input. So that's the selector that we just got, dot fill. So what are we going to fill the text box with? Well, we're going to type in keyboard. So this time we are doing an action. And so actions, in this case, we're using fill. You could also use click or type. This is just a way to interact with elements just like a user would. So after we've filled that, we're going to do another action. So here we have page.locator, and now we're combining our searching for an element, the search button element, and the action, the click, into one line of code. Clicking the button that has the ID search button. Now we're going to wait. So I'll do await page.wait for timeout, and we want to just give it some time. We'll give it 500 milliseconds. So sometimes we need to wait for a page to update. So this is one way, but Playwright also has other waiting mechanisms. And then we're just going to do some testing now that we've got the setup. So here we get the products by doing page.locators, and then we look for product card, the class, and we're going to expect products to have count of 1. So there should just be one product because we've added one product to the page based on searching for a keyboard, and there should only be one keyboard on the page. Now we'll do one last expect, and we're going to do page.locator and then find the exact element on the page, and we expect it to contain the text keyboard. And that's the entire test, so I need a closing bracket here. And that test is complete. Okay, let me talk a little bit more about locator strategies. Basically, I mean how to find elements on a page. This is one of the most important skills in testing. Now, I'm just going to put some code right in here just for now so I can explain something to you. So you can locate by ID, by class, by text content, by just doing text equals add to cart, by role or accessibility, so that with the role of the button with name login, by placeholder text, or by combining selectors. Basically any CSS you can put in there. My recommendation, prefer locators that are stable and meaningful. IDs and data test ID attributes are great. Text content works well for buttons and links. Avoid brittle selectors that depend on exact CSS structure. So let me just delete all this for now. We'll save this. Now we're going to look at another test file. I'm going to go into the cart.spec.js, and we're going to look at a more complex test, which is testing the shopping cart. So we have the stuff before, like the imports, describe the block name shopping cart. We have the for each, which is always going to be the same. And let's look at this test called should add item to cart. So notice how there's a few different elements. The first is to perform an action. So basically, the action is to add to cart. So basically, we click to add to cart on the first product. Then we're going to verify the immediate action. This is the immediate feedback. We're verifying the feedback, which is the toast message. And then finally, we are verifying the state change, which is the cart count has been updated. This pattern, which is action followed by verification, is fundamental to good testing. And we can look through this testing file. We can see a lot more tests that are following that same pattern. So like, for instance, we are navigating to the cart. We're verifying that there's been some immediate feedback, and then we're verifying the state change. So when you're creating tests, that's a very good pattern to follow. Again, you can check this out yourself to see the other tests on here. Okay, let's look at another testing file. I'm going to go into the auth.spec
forms.js. Forms are everywhere in web applications. So here we're going to look at testing the login form. So it's going to start very similar to our other test files. Now I'm going to just scroll down here to this one right here. Should log in successfully with valid credentials. We're going to follow the same pattern as before. One thing to see though is that we're on a different page. We're on the login page here because we have this before each here. So first we're going to fill in valid demo credentials into the login page. We're going to submit the form. We're going to perform the action. Now we just verify the feedback. And then we verify the state change, which is that it's been redirected to the home page. Well, I guess we're not verifying any. Yeah, we are verifying. It's not, even though, okay, this is something important to say, even though we don't have the expect, it's still checking that this happened. The test will fail if it never gets to this URL, even though it's not a specific expect to contain or something like that. If one of these actions doesn't work, the test fails. And then we are going to go down to this test here. Should show error for mismatched passwords. Like I said, it's important to test for error handling. Now, this is going to follow the exact same pattern as before, but using different credentials. So first it fills a password, but then it confirms the password with a different password. And then we are expecting the error message to be visible, and then it should say passwords do not match. Testing both success and failure scenarios is important. Happy path tests verify things work. Error handling tests verify things fail gracefully. Now I'm going to go into another test file, which is the checkout spec.js. Let's look at a full end-to-end test, which is the checkout flow. So I'm going to go down here to should complete checkout successfully. So this is a very long test because it's going through the entire flow. So it's going to fill out an entire multi-step form. So you can see how we use checkout, or I mean, we use the fill for test inputs. We use select option for drop downs. We're still filling here, and then we are going to use multiple assertions to verify the outcome. So a bunch of fills, and then we have to assert multiple things to verify the outcome. Now let's open another test file, which is the API spec.js. Playwright isn't just for UI testing. It can also test APIs directly. So here we have the base URL of our API, and then we have our first test. We're testing a GET request to /API/products, and we want to check if it returns all products. So we're going to await this GET request to the URL. We want to expect that the response.ok, that's going to be truthy, so it's going to have a good request, and that the status is going to be 200. We're also going to await the JSON response. We're going to expect that it is an array of products, and then we're going to expect that the length is going to be 6. So we got 6 products when we go to this API URL. And then if we go down here, we can look at another one. We have the should add item to cart. API tests are faster than UI tests and great for testing backend logic. So before, we were testing, basically simulating the browser, but here we're not simulating the browser at all. We're just making sure the API can handle adding items to the cart. So we're going to the URL, and then so we're posting at the URL, sending this data, which is going to it should add the item to the cart. Then we check to make sure the response says add to cart. We check to make sure the data.length is 1 because that should have been added. And then we check that the data, the product ID and the quantity have been added correctly to the data. So combining UI and API tests gives you comprehensive coverage. Let's talk more about running tests and how to run them effectively. So I already showed you running npm test to run all tests, but there's different ways to run tests. We could do npm run test, but I can put headed. So this is going to run in headed mode, which will show a browser. Okay, you can see that the browsers are opening. The browser opens, and you can actually see the browser running in headed mode, and you can see what's actually happening in the test. You can see how quickly the tests are running. They're running very quickly. So the first few tests were just of the API, so there was no browser that popped up. But a bunch of them will actually use the browser when the tests are running. And then we can also run tests with UI mode, interactive. So I do npm run test and then just do UI, and then we'll see how this can be in interactive mode. So basically it's opening Google Chrome for testing, and then we can basically interact. We can run different tests. So I had to hit the play to run all the tests in this block here. And this is just going to give you a lot more information about your tests. We'll close this for now. You can also just run a specific test file. So I can do npx playwright tests / cart.spec.js. But before I run this, I'm going to go into the tests, and I'm just going to change one of the tests. So let's say that we're expecting it to say item added to cart instead of added to cart. Now the test is going to fail because it's not going to say item add to cart. It's going to say test added to cart. I just want to show you an example of a failed test also. So now we're only going to run that test file instead of every file in the test directory. And sometimes the test will take a little while to run. So you can see we now have a failed test. Our first test is failed, but the rest of them that we did not change are still passing. So sometimes you would have some failed tests, some passed tests. So we actually have multiple failed tests because the first time it's running all the tests on Chromium, then it's running all the tests on Firefox, then it's running all the tests on WebKit, and every time it's running that test that's a failed test. Okay, now it's going to open up our report. And you can also just do npm run test : report to open up this if you somehow closed it or it didn't open correctly. And now this is where we can see we have some failed tests. The failures are coming to the top here. We can sort by failures or sort by past tests. But if I do all, it's going to have our failures at the top. Again, it's that one test, but it's being run on different types of browsers, and it failed every time. Another thing we can do is to run tests that's matching a pattern. I'm not gonna run it this time. I'm just showing that we can do npx playwright test-g login. So it's gonna basically run all the tests that has the word login. Now I'm back to the website that's showing the test. I'm gonna click into this, and when we click into the failed tests, we can see a lot more information. So we can see the expected substring, the string it got, the call log. We can see the test actual code here. Now we can see the test steps. And within the test steps, we can see a lot more details, but we can also have a screenshot. This time it looks like it's having trouble showing the screenshot, but we also have this error context, which is going to be a markdown file with all the errors that you can use for additional debugging. Now that you know the basics of writing tests, let's level up. In this section, we'll cover 3 important techniques that separate beginner testers from experienced ones. There's testing edge cases and error handling, mocking API responses, and accessibility testing. These are the techniques you'll actually use on real projects. So let's dive in. The tests we wrote earlier cover what we call the happy path. Everything works as expected. But real users do unexpected things. They submit empty forms, they double-click buttons, they paste weird characters into search boxes. So let's write tests that catch these scenarios. So if you're following along with the code in the description, we have this edge cases spec.js. So let's look at these edge case tests. So let me walk you through what makes these tests valuable. So first we have these search edge cases. So should handle empty search gracefully. Basically, it's going to click the button without typing anything first. And we should expect the product cards to have count 6. So meaning that all the products are still there. So this is actually a common thing that people do. They search without typing anything. So some apps would crash or show errors, but ours should show all products. Then we have this special characters test. So it should show no results for nonsense search. So here we're just typing in some random characters. So this next one is all about showing no results if there's just some nonsense search. So if we just search for some random characters, we should show that there's going to be 0 product cards. We also want to search for special characters to make sure we handle that. So we're searching for adding basically a script, a JavaScript script or code to a search box. Basically, this is a basic security check. So if someone types HTML or JavaScript into the search box, it should not execute. This is testing for cross-site scripting, which is one of the most common web vulnerabilities. So we should just have no results, and the page should still be visible. And we have a few other ones like handle search with only white space, adding product multiple times, not allowing checkout with empty cart. So it's actually going to fill out the form and try to create a checkout, but we want this toast to be visible, basically the error about the empty cart. You'd be surprised by how many real e-commerce sites have had this bug where someone could try to check out with an empty cart. So there's a few other ones that you can kind of read through on your own. So the golden rule of edge case testing is think about what could go wrong and then write a test for it. Now let's talk about mocking an API response, which basically means sending a fake API response. Sometimes you want to test how your application handles situations that are hard to reproduce naturally. What if the API is down? What if it returns unexpected data? What if a product is out of stock? Playwright lets us intercept network requests and return custom responses. This is called mocking, and it's very powerful. So I'm going to open up my mocking.spec.js, and we have some tests in here for our application. So let's talk a little bit about what's happening here. So page.route is the key method. It lets us intercept any network request matching a URL pattern and decide what response to send back. So in this first test, we're going to simulate the API being completely down, returning a 500 error. So we're doing this route and we're returning this status 500 and returning this body internal server error. And then if we kind of scroll down, we can see the rest of this. The product grid should be empty. So there should be 0 product cards. This tests whether the app handles failure gracefully instead of showing a blank page or crashing. Then we have one that's going to test should handle slow API responses gracefully. So we can see we're going to intercept this route, and then we are going to set a timeout. So it's going to take 3 seconds basically before it continues. It's going to add a 3-second delay. This is great for testing loading states. Does your app show a spinner? Does it remain interactive while waiting? And we eventually are going to just test that it's still usable during loading and that products should eventually appear. So eventually we want to show all the products. And then we have one that's going to test the out of stock. Basically, this lets us control exactly what data the API returns. So in this case, we're returning this data, and we can see it's putting stock 0 for the wireless headphones. So we don't have to actually modify the database. We just mock the response. This makes testing specific scenarios much easier. And then we can just show that there's 2 products and that it's going to contain out of stock, the out of stock indicator. And the final one I'm going to just talk about right now is the add to cart failure. This test only intercepts the post request. So letting get requests through normally, but the post request will be mocked. So this selective mocking is powerful for testing specific failure points, and we can see what happens when we do that. So when should you mock? Well, when testing error states that are hard to reproduce, when the real API is slow, flaky, or costs money per request, when you need precise control over the data, when testing third-party integrations you don't control, and when you should not mock is when you need to verify the real API works, and you should use integration tests for that. Also, when mocking would make the test meaningless. Now let's talk about accessibility testing. There's a lot of people in the world that live with some sort of disability. If your website isn't accessible, you're excluding a huge number of potential users. And in many countries, accessibility is actually the law. The good news is that Playwright makes basic accessibility testing straightforward. The most common accessibility issues are missing alt text on images, poor color contrast, missing form labels, keyboard navigation doesn't work, and the screen readers cannot understand the page structure. So let's open up our accessibility spec.js and talk about some accessibility tests. So if we look at this one, alt images should have alt text or alt text. This checks every image on the page. Screen readers depend on alt text to describe images to blind users. If an image has no alt text, a screen reader just says image, which is useless. So this is just going to go through all of them and just make sure they all have the alt text. The next one is all form inputs should have labels. The form labels test verifies that every input has a way for assistive technology to identify it. Without labels, a blind user encounters a text box with no context. They don't know if it's for their email, password, or search query. So here we're going to expect that they all have a label. Next up is the page should have proper heading hierarchy. This basically checks that your headings make logical sense. Screen reader users often navigate by headings, sometimes jumping from H1 to H2 to H3. So if you skip from H1 to H3, it can be confusing, like a book with like chapter 1 and then chapter 3, but no chapter 2. So this is just going to just make sure that all the headings don't skip levels. And then the final one we're going to talk about is that we're going to check if interactive elements are keyboard accessible. The keyboard navigation test verifies that users who can't use a mouse can still navigate. Many people with motor disabilities rely on keyboard navigation. If your buttons and links aren't reachable by pressing tab, they're basically invisible. Okay, I have my terminal open. I'm running the command to run these tests. And we can see most of them are passing, but a few of them are actually failing. That's actually a good thing. It means we found real accessibility issues that need fixing. So this is the power of accessibility testing. It catches problems that visual inspection misses. For a more comprehensive accessibility testing, you can use tools like AxeCore with Playwright. It automatically scans for WCAG violations. You can use Lighthouse CI, which is Google's accessibility auditing tool, Pally, which is a command line accessibility testing. Here's just a quick example of using Axe Core with Playwright. This single test checks for dozens of accessibility issues automatically. So just as a quick recap, for edge cases, you need to just test the unexpected, empty input, special characters, rapid interactions, and error states. These are where real-world bugs hide. Also, mocking is important. Control your test environment by intercepting API calls, test failure states, slow networks, and edge case data without modifying your backend. And accessibility. Test that everyone can use your application. Check for alt text, labels, heading structure, and keyboard navigation. These 3 techniques will make your test suites dramatically more effective. Okay, now let's talk about challenges of traditional testing. So now that you've seen how to write tests with Playwright, I'm going to be honest about some of the challenges. First, there's a significant learning curve. To write effective tests, you need to know a programming language, JavaScript, Python, etc., the testing frameworks API, CSS selectors or other locator strategies, async await and promises, best practices for reliable tests. This takes time to learn, and not everyone on a team may have those skills. Also, there's the maintenance burden. Basically, tests need maintenance. When your UI changes, selectors might break, test flows might need updating, assertions might become invalid. A single UI redesign can break like tons of tests, dozens of tests. We also have the flaky test problem. So end-to-end tests are often flaky, which means they sometimes pass and sometimes fail without any code changes. This can happen because of things like timing issues, network variability, browser inconsistencies, dynamic content. Flaky tests can erode trust in your test suite. Also, writing tests takes time. For the checkout test, we saw I had to identify every form field, figure out the right selectors, handle the form submission, write assertions for success, test error cases. This was about 50 lines of code for one flow. Multiply that by every feature in your application. So I want to basically tell you about a different way of writing tests, which is AI-powered testing. Artificial intelligence is transforming many aspects of software development, and testing is no exception. So AI-powered testing basically uses tools like machine learning and natural language processing to generate tests from plain English descriptions, automatically identify elements on the page, maintain tests when the UI changes, detect potential bugs and issues. So instead of writing things like page.locator, and then putting the ID first name .fill, and then putting what you're trying to fill in with, you might just say enter John in the first name field. So AI testing has some benefits. Accessibility. So team members who can't code can still write tests, like QA analysts, product managers, any stakeholders. We have their speed. Describing a test in English is faster than coding it manually. Maintenance. AI can adapt to UI changes automatically, reducing the maintenance burden. And then coverage. More people creating tests means better coverage. So there's a few ways to write tests with AI, including just going to like ChatGPT and asking for tests. But in this course, we're going to be using Kane AI from TestMu. They're a Gen A native testing agent that lets you create and run tests using natural language. And like I mentioned earlier, Kane AI provided a grant to make this course possible. And I'm going to give you a hands-on look at how it works. So Kane AI, there's a few things that make it interesting. You can write tests in plain English. It supports web and mobile applications. It exports to multiple programming languages. It auto-heals tests when the UI changes. And it integrates with CI/CD pipelines. Now, something to keep in mind. AI testing tools are powerful assistants, but they don't replace human judgment. You'll still need to decide what to test, review AI-generated tests for accuracy, handle complex edge cases, and understands what the tests are actually doing. So think of AI testing tools as a productivity multiplier, not a replacement for testing knowledge. So let me show you how Kane AI works in practice. So I have my TechMart application, and we're going to use Kane AI to do some testing. Now, normally Kane AI is going to be working on websites that are all already live on production. So we're going to have like a live URL. Right now, this one is just running on localhost. So I need a way to get my localhost website to be accessible from the internet so I can test it using TestMu and Kane AI. So I'm just going to use Cloudflare to create a Cloudflare tunnel. Now, if you already have your website hosted somewhere, the problem solved. I can do brew install Cloudflare, and then we still have our server running on my other terminal tab, and then we're just going to do Cloudflare tunnel -s URL and then localhost 3000. Now it's hopefully getting everything set up right now. Okay, and if I zoom out a little bit, this will be easy to read, but it says your quick tunnel has been created, and then it gives me a URL. So let's test this out. Okay, it's working. We have a publicly accessible URL for our website that's running locally. Okay, now I'm over on testmuai.com, and you can either do get started free or log in. Okay, and there's tons of different types of testing you can do on here, but we're going to go over to Kane AI. I'm specifically going to go over to the agent. And here is where we can just use natural language to create tests. And we can test on a desktop browser, mobile app, or mobile browser. So I'm just going to keep it on desktop browser. Okay, I just put in all this. So first go to this website, then make sure the title contains TechMart, check that the text welcome to TechMart is visible, then scroll down and make sure at least 4 product cards are visible. And then I just click this button to start the session. And we're going to see that we have our browser on the right side, and then what's happening is on the left side. So it's giving us our test plan. We can make some changes if we want, but we'll just approve this test plan, and then we'll see what it comes up with. So you can see it's opening the website in its sample browser that it has. Okay, now it finished creating all the tests, and we can see system idle. So it basically went to the website, it checked that welcome to TechMart is visible, it scrolled down, it verified that at least 4 product cards were visible, and so I'm going to save this test. Okay, now we can see all the different steps. So go to the URL, check if the heading contains TechMart, assert that that title equals true, then check to see if that text on the page, assert that it's true, scroll down, get a count, and then assert that that count is greater than or equal to 4. So now we can go into the code. This actually writes real code. So we can actually just go and view the code here. Now, it is Python code. It's not JavaScript code like we were talking about before, but all the same principles apply in this Python code and using Selenium. Now, you're never going to really have to do anything with the code, but just know that it has code, so to make sure that it can rerun the test the exact same way every time. And we can always execute the test. Again, if we go to the test summary, we can now execute the test. So if we make changes to the site, we just execute the test again. So we can make sure that the tests all pass. And it's going to automatically create a description of the tests, and then we can set some preconditions. But all this stuff, we can like add settings, we can add tags, and we can go into the issues, the suggested issues, and this is a potential issue we could have. And then we can also have different versions of the test. So we have our version history there. Now I'm going to add a tag, which is just going to be TechMart, and we'll save. Now we have a tag associated with this. Now I'm going to try creating another test that's going to have some more user interactivity. Okay, this time we're going to go to the website again, click on the search input field, type keyboard in the search box, click the search button, make sure only one product card is visible after searching, and that the product should be the mechanical keyboard. So I'll just start the process here. And then it'll give me a test plan, and I can just approve it, or if I want to change it first, I could. And now I'll just wait as it goes through and tests everything and creates the test. And you can see it's continuing to do everything and test everything just like I described. Okay, it finished and it created all the tests. So I can just save this test and it'll take me to the page where it's going to show all the different steps to do all the interaction on the page. And then we have the description here. Again, we have the code. The code generation is still in progress, so we basically have to wait till it's done, and then eventually we can rerun the tests by just clicking execute test. For now, I'm going to add a tag to this, and we'll save the changes. And here we can actually sort our tests. So I have all my TechMart tests in my TechMart folder, and that'll make it easier to get all of them together. Now let me show you another really cool thing over on the code tab. So it automatically generates code in Python, but let's say we want to generate code in something else like Playwright. That's what we were learning earlier in this tutorial. We just click generate new code. Now this is a feature that's about to be implemented, not quite yet, but we choose a framework, and then this is going to be coming soon. You can just click the Playwright and then choose JavaScript, and then you can create the JavaScript code, so it's a code that you're more familiar with for your project. Then that allows you to review and customize the generated code, integrate it into existing test suites, run it in your CI/CD pipeline, and we can already download the code. We can already download the current code, the Python. I just click this button to download the Python code. Now, one of KaneAI's powerful features is the auto healing. So basically, imagine our developers change an ID, like we have this input. What if we change the ID of the input to a different ID? Well, in traditional testing, this would break our tests. But KaneAI understands the intent of the test, not just the exact selector. So when it can't find the original element, it looks for alternatives that match the original purpose. This really reduces test maintenance. Now we can also use KaneAI for API testing. So let me show you how we can add an API in a web test. First of all, instead of typing into this box here, I'm going to click the author browser test. And I'm just going to keep the default options. Now this is also a way how you can test on specific mobile devices, but I'm going to just click author test. And then it's going to get everything set up here. Okay, now I have manual interaction turned on. Now there's two things we can use this for. We can use the manual interaction to actually manually go to a website, manually try things out, and then KaneAI will actually record everything we're doing and create a test based on our manual interaction. But I'm not going to do that. I'm going to actually do an API test. So I put a slash to open up these special commands I can do, and I'm going to do add an API. And now I'm just going to paste in my URL here, which is at /API/products, and we have it as a GET request. Now this is basically the curl command. Now we can also set up the parameters, authorization, headers, body, settings. For this API, we actually don't have to do any of that. We're just doing a GET request. And then we will just click send. And then to actually execute the API, I'll turn off the manual interaction. And it'll execute the API. And it returned a 200 response. So in this case, that would be a successful test because the API returned a 200. So now I can just save the test. And then it says the user will perform the necessary steps to execute an API request. So now we can make sure, so the test will pass if the API request is successful. So that's how you can test APIs with Kane AI. So I can build comprehensive API tests this way and combine them with UI tests for complete coverage. Okay, let's wrap up with some best practices that apply whether you're writing tests manually or using AI tools. First, you're going to want to make your tests readable. Anyone looking at a test should understand 1, what it's testing, 2, how it tests it, and 3, what the expected outcome is. So good test names help. Like should display error when password is too short. That's way better than just like test123. You also want to keep tests independent. One test should not depend on the outcome of another test. This means that each test sets up its own data. Each test cleans up after itself, and tests can run in any order. Also, you want to use page object pattern. So for larger test suites, consider you should use the page object pattern. Basically, instead of interacting with elements directly, you create objects that represent pages. So you can see this example on the screen right now. This makes tests cleaner and maintenance easier. You also want to integrate with CI/CD. Tests are most valuable when they run automatically. You can integrate your tests with your CI/CD pipeline so they run on every code change. KaneAI actually makes this pretty easy with its API. You can trigger test runs from GitHub Actions, Jenkins, or any CI tool. Finally, remember that automated tests don't replace all testing. You still need exploratory testing for finding unwanted issues, usability testing for user experience, security testing by experts. Automated tests catch regressions, humans find new problems. So here's a practical guide. So you can use traditional Playwright tests when you need precise control over test logic, you're testing complex edge cases, you want testing your code base. But KaneAI can be helpful when you want to prototype tests quickly. Non-developers need to create tests. You want reduced maintenance overhead. You need cross-browser testing at scale. And many teams can use both approaches together.
Okay, let's wrap up what we've learned in this course. We started by understanding why testing matters. Bugs are expensive and testing is your insurance against costly mistakes. We learned the testing pyramid, unit tests at the base, integration tests in the middle, and end-to-end tests at the top. Each type serves a purpose, and a healthy test suite includes all three. We got hands-on with Playwright, writing tests for our TechMart application. You learned how to navigate pages, interact with elements, and verify outcomes using Assertions. And we explored AI-powered testing with Kane AI. You saw how natural language can be converted into working tests, and how features like auto-healing reduce maintenance burden. Here are my key takeaways. Start testing now. Don't wait until your application is complete. The sooner you start testing, the more value you get. Focus on what matters. You don't need to test everything. Prioritize the features where bugs would be most costly. Use the right tool for the job. Manual coding for precision, AI tool for speed and accessibility. They complement each other. Integrate your tests into your workflow. Tests that don't run regularly don't provide value. Automate your test execution. Thanks for watching this course. Happy testing.